Okay, let's get started. One of the things that we do in this course is we spend a lot of time reading code. Now this is a really good way to learn because you don't have to understand what the code is doing at first. You just have to be patient and explore it a bit at a time, and you'll find that as you do that you learn more and more how to read code, and once you know how to read code you get to the point where you know how to kind of come up with ideas on your own and what to do if your first idea doesn't work. So in this notebook, I have some code that's going to do some things with word frequency, and we'll see how that works as we go along. Now this cell right here, I'm just going to highlight it over on the right hand side. This cell right here includes a Mathematica expression. It's okay if you understand this, but I don't actually expect you to understand it to get something out of this. And I'm just going to show you what happens when we run this code, or in Mathematica's language, what happens when we evaluate this expression. So I click in this cell, and then I hold down Shift and I press Return or Enter. And it runs the code and it creates the output. If we look over on the left hand side here, you'll see that there are two little blue labels. One tells us that this label in, this was the expression that was the input, and the out that corresponds to that is what came out when we ran the code. Now if we were to go back and click on this cell and hit Shift and Return again, we're going to evaluate the code again. And when we do that, we notice that the numbers over on the left-hand side here have changed. So the last pair was 45 and this pair is 46. Each time we rerun the code, we create another one of these input-output pairs, and we can refer back to these as we'll see in a couple of lessons. Now when we look at this code, just the first thing we see when we look at it is we see that some of the text is actually in boldface. Things like take largest and word counts are in boldface. Things like text and Alice in Wonderland in here are in a gray font. We notice that these words are capitalized. The initial letter of each word is capitalized, and that every Mathematica expression here has a form that looks like this. A word with an initial capital letter followed by a square bracket. Then there's a matching square bracket that goes with that. So if we click right behind this first square bracket here, we see this other one lights up in green over on the right hand side. And what that tells us is it tells us that those two brackets go together. So if we start to feel like we're not sure where we are in the code, we can always click right between a word and its square bracket and, highlight the square bracket, and Mathematica will highlight its matching one. So this is the one that matches the word counts, this is the one that matches string take, this is the one that matches example data. We can also do this trick by highlighting one of these curly braces, and that shows us that the matching curly brace is over here on the right hand side. Notice also that the input is mostly in boldface and the output is in regular font. This helps us visually to determine what is what in the two when we're just looking at our code. Now, as I said, I don't necessarily expect you to understand what this is or what this does, but one way to start to figure out what it is or what it does is to copy code and then evaluate it again. So the way that we do that is we go over to the right-hand side here, and we select the cell bracket. That's this little bracket on the right-hand side, and that is a way to select this entire blob of code. If we hold down Command and C or Control and C on the Windows machine, we can create a copy of that text, and we can paste it in and try creating another copy of that code that we can do something with. So I'm just going to paste it in right here into this section of the notebook that talks about copying and modifying it. So we now have a copy of this code, and I'm going to evaluate that code just so we can see what it does again. So Shift and Enter. So that's the output of that code. Now if I were to create a copy of it right below and paste it in here, I can take this word take largest and I can replace the word largest and make it smallest, like that. And if I hit Shift and Enter on that cell, I get a different set of words in this expression here. What's happening if we just look at this is we can see that the output of the first expression, the one that we're exploring, has a number of words, in this case common English words, the, and then a little arrow that points to 10, of points to 7, her points to 7, and so on. And we asked for the largest. So whatever we're measuring or calculating here, the apparently is the largest one because it's associated with 10. Alice is associated with 4, rabbit is associated with 3, and so on. If we take the smallest ones, we see that they're all associated with 1. It's, flashed, waistcoat pocket, seen, and so on. Now if we were to copy this code, again, and try replacing a different value, let's say we replace this 1003 with the number, say, 100, much smaller number, and evaluate that, we now see a series of words, and each one, there's only one. Each one points to 1. So Alice pointed to 4 before, and now Alice points to 1. If we just stop and look at the code, we can see this section in the middle here that says Text, Alice in Wonderland, which makes us suspect that probably what we're doing has something to do with the text of the book Alice in Wonderland, and that is in fact the case. And you might wonder, well, what about a different text of some sort? What if I type in, say, the Bourne Identity? What happens then? Shift Enter. Gives me a bunch of red error messages. So it says the Bourne Identity is not a known entity for the collection text. Use example data text for a list of entities. Well, let's try that. We can say example data text. Shift Enter. And now it shows us a collection of stuff. Each one of these appears to be a text that we can do something with, and in fact that is the case. In Mathematica, each of these texts are built in, and we can try exploring different commands, different text processing commands with them. So for example, we see The Raven, the poem by Edgar Allan Poe, is an example text. So if I were to copy this line up here, this cell again, and paste it in, and change this to The Raven, try running it, it now gives us a different series of words pointing to numbers. And if you're familiar with the poem, you'll recognize that midnight dreary and pondered and weary and curious volume are all words from that poem. In Mathematica, things can be of different kinds. So for example, if we're not sure what something is, we can use a command called head. So if I'm not sure what 1003 is, I can evaluate this expression, head 1003, and it tells me that it is an integer. That is a whole number that could be positive or negative or 0. We can try this on other things. For example, if we say head of this text in quotation marks like that, it tells us that that's a string. In many programming languages, including Mathematica, a string is a sequence of 0 or more characters, and it can include things like letters and digits and punctuation and so on. We can use the head command to explore a number of things from our code. So for example, if I go up here and I highlight this expression inside of example data, and go Command C or Control C on Windows to copy it, I can paste that thing in here, and then I can type head, square brackets. Notice that there's no space between the command and the square bracket. I need a square bracket at the end, Shift Enter, and it tells me that that thing is what is called a list. What's inside that list? Well, we can see that there appear to be two things, text in quotation marks and the Raven in quotation marks. In other words, there are two strings inside of a list. Now, so this process, I'm just going to scroll back up here gradually so we can see this again. This process allowed us to understand some of what this code does simply by copying it and making changes. So even if we're not entirely sure what this whole expression does, we know, for example, now that this is a string, that this is a string, that those two strings are gathered together inside of a list, and that this whole expression in green here, example data with square brackets, a list inside, and more square brackets, is in its own right a Mathematica command. So in Mathematica, we build up expressions by wrapping commands inside of one another, what's called nesting. And this nesting process allows us to build more complicated expressions from simpler ones. Down here, we learned that we can use the example data command, and we can just give it this string text, and it will show us a list of all of the texts that are built into Mathematica for us to experiment with. Another strategy that we can use if we want to understand code is we can start breaking the code into smaller pieces. So if we look at the code that we were just using, inside we have this example data command, and then we wrapped a command around it which is called string take. String take, assuming that the example data command gives us the text of Alice in Wonderland as a string, which is in fact what it does, then string take takes a certain number of characters from that string. So for example, if I were to change this from 1003 to say 100 and hit Shift Enter to evaluate the expression, it shows us the first 100 characters of Alice in Wonderland. So this is chapter 1, called Down the Rabbit Hole as chapter title. Alice was beginning to get very tired of sitting by her sister on the bank. So those are the first few words of Alice in Wonderland. And what we asked for in our expression before was 1003 characters from the beginning of Alice in Wonderland. If we take this again, Command C, Command V, and evaluate it, but this time ask for all 1003 characters, we see that it returns about a paragraph worth of text from the beginning of the book. Now that we know what that expression does, if we take that whole expression that we just looked at and we say, okay, that returns the first 1003 characters of Alice in Wonderland, this next command says word counts. Well, maybe that counts the words that appear in that text. Let's hit Shift and Enter. It returns this output to us. We still haven't talked about what this output is, but it returns this output to us, and it tells us, for example, that the word the, in lowercase, appears 10 times in that first section of Alice in Wonderland there. The word her occurs 7 times, and so on. The word beginning, if we look down here at the bottom, occurs 1 time. Finally, the last thing that we did in our expression, I'll just go back up and make a copy of it. This was our original expression. The last thing that happens, I'll just go down here and paste it into the bottom. Was now that we have these word counts, we say take largest, and that has comma 15 at the end of it. So what this is saying is take this whole representation here, this is called a data structure, take this whole data structure and return the largest 15 elements. And if we do that, this gives us what we had at the very beginning.